What's up, guys? This is Gabe from SNP Speed Innovations. Today we're going to bring you some shop tech talk, and the topic of that today is the Sand Drag Jeep 4.0 liter and trigger patterns. This is a very important topic. Most people overlook it. They just figure they'll throw some sensors in it, plug it in, and away it goes. It's not necessarily how it works. This is the sand drag truck that we've been working on for a long time. We did all the wiring on it, the coils and the injectors, did a full complete harness, Hltech install, battery cables, everything, the whole 9 yards. And what this is a 4.0 liter, and the way that they do the factory trigger pattern is off of the flex plate. Now the flex plate has a series of square holes and rectangles that the factory Hall effect sensor picks up. What it ends up being is 4 pulses in even space, 4 pulses in even space, 4 more pulses in even space. What that gives you is 18 teeth with 3 groups of 4. It's kind of complicated. Most systems out there don't have a trigger pattern for it. Hltech does. So when we took on this project and the customer bought all of his Hltech stuff and decided to go this direction, before even contacting us, he's been a fan of this sand drag truck there for a while, so that's a Hltech equipped vehicle, so he just wanted to go that direction. So we take on the job, we do the wiring as part of our systems check, and we have a long list of stuff that we check, and we start from the very beginning and check everything. When we wire it, we're touching every aspect of everything that is electrical in this, and we want to make sure that everything is 100% ready before we start firing it. And we do a systems check. So everything tested perfect. We have power everywhere we need to. We have our injector signal is to every cylinder it should be. Our coil signals to every cylinder it should be. Everything works. Everything's perfect. We haven't been able to test the nitrous output yet because we need RPM for that. Once we get into cranking the thing over, trying to figure out, okay, let's see if the trigger pattern works. It doesn't. Something wrong. So we start looking into a distributor. We pull the distributor, we put on an oscilloscope. It is a Hall effect sensor, and if you don't know what a Hall effect sensor is, there's 2 different types of sensors, magnetic and Hall effect. Yes, they both have a magnet, but they don't operate the same. The magnetic is a self-generating electrical voltage output in an AC form, and a Hall effect sensor has a volt reference going to it, and it's a square wave from 0 to 5 or 0 to 12. Whatever the voltage coming in is what it should be coming out, and more of a square wave pattern. Okay, so what happens is as that ferrous metal sweeps past the magnetic pickup sensor or the Hall effect pickup sensor, it generates electricity, or it triggers the electricity output. So we tested a distributor, and we had 0 volts coming out of it at all, and we can measure it pretty down in the real low tenths or even 100ths of a volt through the oscilloscope. So we put a new sensor in it, bench tested again, spun it with the drill, 0.5 volt. Not 12, because we have 12 going into it, not even 5, a 0.5 volt. Change that sensor out again, doing the same thing. So still trying to figure out what's going on there. But with the Hltech, that makes it life a little easier, because what you can do is you can come into custom trigger patterns. So you can do a reluctor, which is a magnetic style, Hall effect, which we just talked about that, or a custom. A custom means that you can go in and select stuff like you want a DC current or AC current. You want to pull up a resistor internally so it actually amplifies the signal that it receives by 5 volts internally. You can do that. Reference ground, which means it takes the ground signal that would normally go to it and it just kind of neutralizes it with the rest of the system, and a few other options. And as some of that, it also gives you the option to come in here and set up your arming voltage, your activation voltage. Activation meaning when it sees over a certain amount, activated as or accepted as a signal. And the arming voltage means if it sees this volt, get ready, because the signal is about to come. This way it doesn't give you a false signal in any way. So working with the awesome guys over in Hltech, Kentucky. We worked on it and worked on it. They even remoted into my laptop. I'm not used to that. I'm used to remoting into somebody else's. And we tried everything we could, and we just can't get it to work right. We can get our synchronization, which is the cam and crank sensor synchronizing. We can get that to go away, but we had a triggering error, and we noticed we got 600 cranking RPMs. We have the spark plugs out. Yes, it's going to spin a little bit faster. 600 is a bit much. So I kind of got a little fed up with screwing with this factory sensor. So I went through my box of magnetic and Hall effect sensors I have. Just a bunch of used sensors that came out of some old vehicles. And I just kind of quickly, me and Wally there. What's up, Wally?
Hey guys,
we just kind of threw together a quick bracket, threw some vice grips on it, put a magnetic sensor in it, changed the wiring real quick, going to the computer. We changed it over to a reluctor inlet, which is a magnetic style, and bam, okay, well, we have some form of synchronization, but we're getting a triggering error, tons of errors, lots of errors. Okay, now we know that the distributor is not the problem. It's got to be something related to the crankshaft sensor. So we noticed earlier, because we made the sensor for it. Now on these Jeeps, if you don't know, they have a 3-wire Hall effect sensor that goes into the bell housing to that same ring gear reluctor wheel that we were talking about earlier, where it's got 3 evenly gapped spaces of 8. So earlier we had a borescope. Yeah, we use borescopes, oscilloscopes, voltmeters, everything we can, because in this industry you can never have too much stuff, but you're only as good as your equipment, and the more equipment you have, the smarter you are, but the better your testing results are. So we're not like dead in the water going, I don't know what the problem is. Well, let's find out what the problem is. We have all this testing equipment, let's see what's going on. So we built a bracket, put a nice, real nice Hall effect sensor in it, one of the best ones Hltech has, and it's worked really well. We did the same thing in a Jeep that won the Baja 1000 a couple years ago. It's the same motor, newer, the same motor. So down inside there, you can kind of see the lights on right now. We have the borescope, and this is kind of tough, but if you look right there, you can see that there's some threads, okay, right there. Those threads, that's the Hall effect sensor. That square box, those are the pickup sensor, the pickup teeth in there. So basically, as it sweeps across the empty pockets, it's just as if there's a gap there in a trigger wheel, and it comes across that ferrous material, which in this case is just a piece of flat. It picks it up as a tooth pickup. So it works just like a tooth trigger wheel. It's the same concept. It works the same. So we can see what it's supposed to be, but once we stuck a borescope down there, and then we came over here to the distributor, or to the harmonic balancer, and right there you can see we got TDC, and it goes down to that line right there. So what we did is we stuck the borescope down there, we rotated the motor 1 full rotation, and we counted all the teeth. Because before we did that, I took my 2-channel oscilloscope and I said, let's see what that actually looks like. And what I got here is kind of tough to see, but up here in the top, that is our camshaft position sensor, which is on the distributor. Yes, the signal looks a little funky. I'll show you why in a second. That is a magnetic sensor, so it's going to be a little wavy like that. It's supposed to go up and down, but we had to, wouldn't register it on the positive side. It only registered on the negative side, which is why it's falling and not going up, but same result, it works. All these fuzzy lines down here, each dark section is 20 teeth, 20 pulse counts. So each section between is that gap we were talking about. What we have is 1 full rotation of the distributor from one side to the other, which is our 720. Now we have 360 degrees in a rotation, but the crankshaft rotates twice, so that's 720 for 1 full complete circle or cycle of the distributor, which is 1 full complete 4-stroke cycle. So when we spread this apart and look at it, what we see is we have 20 teeth. I'm like, that's odd. So are we getting double counts from something? Are we picking up a sensor where we shouldn't be? We're picking up some ferrous material where we shouldn't be? Is some signal interference going on? What's going on here? That's what led us to grabbing the borescope and checking the physically checking how many teeth we got, and we confirmed it. We have 20 teeth. with a space, another 20 teeth with a space, another 20 teeth with a space. Once we confirmed our oscilloscope matched, and our oscilloscope, we have 2 oscilloscopes, this is one I travel with. We know we got a solid signal coming out of the distributor. We know we got good signals going into the computer. So what is going on here? Well, what we found is that this is a 1989. And what was that year gap from 1984? 1984 to 1990?
1991 to 2000.
Okay, so from 1984 to 1990 is a 3 evenly spaces of 20, and from 91 to 2000, right? 91 to 2000, we have the typical 3 evenly spaces of 4. So the moral of the story is, yes, we have triggering errors. Yes, we have synchronization errors, and no, we're not dead in the water. We have equipment. Let's test and see. And not everybody has this option, but we can go through and check and recheck. And what we found is what we have, we cannot work with. Are we dead in the water completely, or is it over with? We throw in the towel? No. Customer's gonna show up, talk to him, explain the situation. He's gonna come down here, change the flex plate. We're back in motion. We had a couple other options. One was to put a crankshaft sensor in front of the balancer. Everybody knows my opinion on that. I hate that because if that thing throws a belt, that belt's going to wrap all the wires up and tangle it into the belts, and it's going to give you a wiring nightmare. We can put some type of a pickup sensor, 36-1 trigger wheel in there, and put a single sensor. But hey, we got all these coils, and we can do this sequentially. A Hltech Elite 750 can fire direct fire, coil unplug with the injectors one at a time. So why not have the best of both? So we can remove this. We know that we got a good enough signal. Even with a 0.5 volt, we can make that work with the Hltech. That's the beauty of having the custom triggering pattern in there. So we won't need this. It'll have the factory sensor working. That real nice $200 crankshaft sensor we put in there will work just fine. It's Baja 1000 tested and proved, and we'll be able to have this thing up and running and spraying a whole lot of nitrous through it in no time. So anyway, that's where we're at with it. Want to give you guys a little bit of technical knowledge here, share our experience with you, and express the fact that yes, you have a problem, does not mean that you're dead in the water. There's ways to test. Testing is everything, and that's why we do what we do. That's why we have the customers that we do. They come to us because they trust us, because we don't just throw in the towel and say, I don't know, it just doesn't work, I don't know. That's not what we do. We dig deeper, we chase it. So that's it. That's our shop update. Put this up on YouTube and all that good stuff. It's kind of a long video. It is in depth. I get that. I apologize for that. But it gives you guys some insight as to what we do and what you're supposed to do. And when you have a problem, let's find a solution, because it's not a problem, it's a challenge. And some challenges are greater than others, but we'll conquer it one way or the other. So you guys have a great rest of your day, and we will keep posting videos. Share, like, and all that good stuff. Thanks guys, have a great day.